indirect proof and inequalities in one triangle. Our objective is to write indirect proofs and apply inequalities in one triangle. Why learn this? You can use a triangle inequality to find a reasonable range of values for an unknown distance. Well, what exactly is an indirect proof? You begin by assuming that the conclusion is false. Then you show that this assumption leads to a contradiction. This is also known as a proof by contradiction. Let's first look at writing an indirect proof. Identify the conjecture to be proven. Second step, assume the opposite of the conclusion is true. Once you have assumed the opposite, use direct reasoning to show that the assumption leads to a contradiction, meaning it leads to the fact that it can't make sense with the given information. And then 4, conclude that since the assumption is false, the original has to be true. Let's look at an example. Alright, so step 1, identify the conjecture to be proven. We're given that triangle JKL is a right triangle, and we want to prove that triangle JKL does not have an obtuse angle. So we're going to assume the opposite of the conclusion. So we're going to assume that JKL has an obtuse angle. It doesn't matter which one you let be the obtuse angle. For the purpose of this proof, we're just going to say let angle K be the obtuse angle. Then use direct reasoning to lead to a contradiction. So I'm going to show you this one because we are going to be doing another one. Alright, well, if the measure of angle K plus the measure of angle L has to equal 90 degrees, because we know that the acute angles of a right triangle are complementary, let's get K by itself. So we're going to subtract the measure of angle L from both sides. Alright, well now we're going to use that whole idea of, well, hey, K is obtuse. That means it is more than 90. Alright, so that means 90 minus L has to be greater than 90. Therefore, the measure of angle L has to be smaller than 0 degrees. Wait, that doesn't make sense. You can't have a measure of an angle being smaller than 0 degrees. That's why the conclusion of the original conjecture is true. Because once you've used this contradiction method, you get to a point where it either contradicts the given or it's saying something that's impossible to happen. So then you can state, well, hey, therefore, triangle JKL does not have an obtuse angle. It can't. Let's look at a couple more theorems first. Okay. So, if two sides of a triangle are not congruent, then the larger angle is opposite the larger side, or longer side. So, think of it this way. The further you spread these two sides out, the longer AC is going to get. And then the reverse is true. So, if two angles of a triangle are not congruent, then the longer side is opposite the larger angle. So if XY is the larger side, that means angle Z has to be the larger angle. Because the further you spread apart the two sides, the bigger the angle is going to be. Therefore, the bigger the side to connect the two ends is going to have to be. If you're having trouble with this, see your teacher. She might have a manipulative to show you how this works. Alright. Consider all cases when you assume the opposite. So when you're trying to use a proof by contradiction, or an indirect proof, you want to make sure you're dealing with all of the cases, because otherwise you're leaving a piece of information out. So for example, if the conclusion QR is greater than QP, the negation, so the opposite of this, is not just that QR is smaller than QP. It's also that QR is equal to QP. You need to have both of those in your proof. So let's try an example of this indirect proof. Alright, so the measure of angle P is greater than the measure of angle R. We want to prove that that means QR has to be greater than QP. Alright, so we're going to start with assuming the opposite of what we're trying to prove. So we're going to assume that QR is not greater than QP. This means that either QR is less than QP or it's equal to. So you're going to basically have two separate cases. One for this one, and then one for the equal one. Alright, so let's look at the case 1 together. If QR is less than QP, then the measure of angle P must be smaller than the measure of angle R. Well, that's all fine and dandy, however, the given says that it's bigger. So that can't be true. It's contradicting what they've given us for information. Take a moment and try case 2. Now that you've had a moment to try case 2, let's look at it together. So if they're equal, that's going to mean that the measure of angle P and the measure of angle R have to be of equal value. That doesn't work. Same reason. It contradicts what they gave us. They told us that the measure of angle P has to be larger than the measure of angle R. So therefore, it cannot be equal. Well, if it can't be any of the other possibilities, that means what we were trying to do in the beginning has to be true. So therefore, QR has to be greater than QP because it can't not be. Try using the theorem to list the angles in order from smallest to largest. Hopefully you got that angle H is going to be the smallest angle because it's across from the shortest side, and then the next largest would be angle J, and then angle G. Let's try doing it with sides as well. Now that you've had a moment to try it with sides, did you end up getting KM, LM, and then KL? As remember, the largest angle is going to be across from the largest side. Alright, let's get a little more specific about triangles. A triangle is formed by 3 segments, but not every set of 3 segments is going to be able to make a triangle. Well, if you had 4, 4, and 7, you could make a triangle, but what would happen if 2 of your sides were, say, 3 and the other one was 7? Well, they would never be able to connect. Same with, say one of them was 4 and the other was 3. They'd touch, but when they touch, they would just form a straight line. So your 2 shortest sides need to add up to something greater than your longest side, so that way you'll end up with a triangle, not either a line or not a polygon. This brings us to that whole triangle inequality theorem. So the length of 2 of the sides has to be greater than the 3rd side. No matter which way you look at it, has to happen. So let's practice. So the first one here, that I wanted you guys to just be able to see it, well, if we add 3 and 5 together, is that greater than the 3rd side of 7? Yes. Okay, so we're good to go. Alright, how about 3 and 7? Mind you, we're putting all the combinations together, so 3 plus 7 has to be greater than 5. Is that the case? Yes, it is. And then we have our 3rd set. So 5 and 7 together have to be greater than 3? Well, that is the case as well. So therefore, yes, this is a triangle. Take a moment and pause the video and try B. Alright, well if we add 4 plus 6.5, we need this to be greater than 11. Well, that gives you 10.5, which is not greater than 11, so therefore, no, it's not a triangle. It only has to happen once. Just because the other two sides might make a triangle when you add them together, like if you added 6.5 and 11, that's bigger than 4. If you add 4 and 11, that's bigger than 6.5. As long as it only happens once, if it doesn't work one time out of the 3, it means it's not a triangle. Let's try finding side lengths. So, the side lengths of two sides of a triangle are 6 centimeters and 11 centimeters. Find the range of the possible lengths for that third side. So there's a range of possibilities for this one. So for the purpose of this, we're going to let S represent that length of the side that we do not know. Alright, we're going to apply that triangle inequality theorem, because you're going to have 3 combinations. So let's start with one of them. So the one you don't know, so S plus 6 has to be greater than your third side. So S plus 6 has to be greater than 11. So solve for S. S has to be greater than 5. Okay. Put together the other two combinations. Alright, now that you've had an opportunity to put together the other two combinations, did you get S plus 11 has to be greater than 6? So S has to be greater than negative 5 if you solve for S. And then for the third one, did you get 6 plus 11 has to be greater than S? So therefore 17 has to be greater than S. Once again, if you're having trouble remembering how to get these 3, just put all your different combinations together. So 2 sides have to be greater than whatever that third side is. Pick 2 other sides, has to be greater than the third side. And then the 2 sides you hadn't put together yet have to be greater than that third side. Once you've done all that, you can then look at your inequalities. One of them is obsolete. If S has to be greater than 5 and S has to be greater than negative 5, which one does it have to be bigger than? Well, it has to be greater than 5 because 5 is already bigger than negative 5. So when you write your finishing touches, you're going to have 5 is smaller than S, which is smaller than 17. So this is the inequality you're looking for in the end. Try this next one on your own. After you unpause the video, an answer will be revealed. Okay, so you have your S plus 22 has to be greater than 17. Then you have your S plus 17 has to be greater than 22. And your last combination is 22 plus 17 has to be greater than S. So, when you solve for S in each of these equations, or inequalities, you end up with S has to be greater than negative 5, S has to be greater than 5, and 39 has to be greater than S. One of your 3 is obsolete. S has to be greater than 5, and S has to be greater than negative 5. So therefore, it's going to have to be greater than 5. So we have 5 is less than S is less than 39. And there's your final result. And that concludes our lesson on indirect proof and inequalities in one triangle.